Solving radical equations. Solving radical equations. Radicals, as you guys know, involve some sort of roots. And you guys typically think of square roots, right? Okay. I want to do a little quick refresher on square roots, though, because this will show up here. Okay. How about the square root of x is really the same as x raised to what power? Does anybody recall? Not 2. It's the reciprocal of 2. 1/2. Yep. A 1/2 power is really a square root. Okay? So if you typed into your calculator 49 to the 1/2 power, what's it going to give you for an answer? 7, right? 25 to the 1/2 power would be 5, because you're essentially doing a square root, right? Okay? Cube root of x is really what? Yeah, good. X to the 1/3 power. Okay? A fourth root of x is really x to the 1/4 power. So if you ever have to do a fourth root and your calculator doesn't have a fourth root button or a way to type in the fourth root, you can instead just do what? Raise it to the 1/4 power. They do the same thing. Okay? So in general, if I have x to the 1/n power, that would be the nth root of x. Okay? Or if I had, let's say I had something other than a 1 up there, if I had x to the m/n power, that would be the nth root of x to the m. Okay? So that's just a quick refresher. You guys did this in Algebra 1. You worked with all of your exponent rules. We converted from radicals to fractional exponents and back and forth. Okay? I'm sure you guys all remember that like it was yesterday. But, quick refresher. Okay? Any questions on this? Anything at all that you can think of? Because if you have got a question, somebody else probably has the same one. So. Alright, so I wanted to touch base on this first, so when you see a fractional power later on, you know it's really just a square root, or a cube root, or a fourth root. Okay? Alright, solving radical equations. Really fairly straightforward. Okay? If I saw the square root of some number equals 12. Some of you know what the answer is, but what would I have to do to both sides of the equation to get x by itself?
Square it.
Square it. Why? Yeah, that's the opposite of a square root, right? Okay, so I would square this side, I would square this side, and my answer is simply what? X equals 144. Okay, now, yeah, I know, they're not all that easy, but you guys get the idea, right? Okay. What if I had the cube root of x equals 4? What would I do to both sides?
Square it up. Not do it or not?
Raise it to the
Third.
third power. I would cube both sides. I would raise this side to the third, and I would raise that side to the third, because raising something to the third power gets rid of a cube root, and I would just have x left over, and that would be 64. 4 times 4 times 4 is 64. Okay? Questions so far? Start making them a little bit more difficult here. Square root of 2x minus 3 equals 5.
Square root it.
I don't want to square root of square root.
The square root off.
How do I get the square root off?
Square it.
Square it. I know what you meant.
What was I
But
saying?
you said square root.
Oh.
We don't want a square root of square root. We want to square a square root. Alright? So we want to square this side. We want to square that side. Because the square gets rid of the square root. All I have is 2x minus 3 equals 25. Add 3 to both sides. Divide by 2, get your answer, right? So add 3, you get 28 over here. Divide by 2, you get 14. Always check your answer, make sure it works. 2 times 14 is 28. Take away 3 is 25. Square root of 25 is 5, it works. But always check your answers, okay? Always check your answers. You may end up getting an answer at the end that does not work in the beginning. Extraneous, very good. Okay, you may get an extraneous answer, an extraneous solution. Okay. When we talk briefly about that, I know we've talked about it before. What is the only value of x that satisfies this equation? 3, right? 3 is the only thing that is equal to 3. Okay. I'm going to square both sides of the equal sign. I'm going to square this, and I'm going to square that.
Plus or minus.
Now what values of x would satisfy both sides, or would satisfy the equation?
Plus or minus.
A 3 would satisfy, because 3 to the second power is 9. But doesn't negative 3 also work if you plug it in?
Yes.
But did negative 3 work in the original equation? So negative 3 is actually an extraneous solution. It works in this equation, but doesn't work back in the original one. So you got to be careful when you square both sides of an equal sign. Sometimes the answers that you end up finding don't work back in the original problem. So therefore, it's an extraneous solution. It does not count as a solution. So just kind of be aware of that. I'll get to one of those here in a minute. I'm going to do a different one though here first. Four times the square root of 2x plus 1 plus 6 equals 14.
Is the plus 6 still in the square root?
It is not. The plus 6 is not in the square root. Okay, the plus 6 is outside of the square root.
Minus 6.
Good idea, minus 6. Okay, here's the reason why I would do that. You don't want to square both sides right away, guys. Squaring that would be awful. You'd have to take that times itself and do a whole bunch of distributing. Okay? You don't want to do that. Let's subtract 6.
Divide by 4.
I would divide by 4. The only time I wouldn't divide by 4 right now is if dividing by 4 gave me an awful fraction that I didn't want to deal with. Squaring this is not that bad. Okay? If I square this, I would get 16 times 2x plus 1. If I were to square this, I would get 16 times 2x plus 1. Not terrible. But I like to divide by 4 right now because 8 divided by 4 is just a nice simple number, right? Okay? So square root of 2x plus 1 equals 2. And now finally, what?
You
Square both sides. Yep.
Yes.
We don't want to square root both sides. We don't want to square root of square root.
I know.
And I know what you mean, but I'm just trying to correct your vocabulary on that. Okay? I want to square both sides because they square, gets rid of the square root. 2x plus 1 equals 4. Subtract 1, divide by 2, final answer, 3/2. 1.5, 1.5, whatever you like. Plug it back in, make sure it works. It does for speed purposes. Just trust me on that. Okay. If I had to summarize what we've done so far, I would say get the radical by itself. Get the radical by itself, then raise both sides of the equal sign to a power. Okay? Two more, real fast. Square root of 3k minus 11 equals the square root of 5 minus k. I think you'd solve that one.
Square both sides first.
Be pretty nice, wouldn't it? Because what happens when you square both sides? Square roots are gone. 3k minus 11 equals 5 minus k. When I square root this, or excuse me, when I square that side, now you got me saying it. When I square the left side and I square the right side, the square roots are gone, and I have 3k minus 11 equals 5 minus k. Get all your k's to one side, get all your numbers to the other, and solve for k. I would probably add k. And I'd add 11. I like keeping everything positive, Dustin. It doesn't matter as long as you do it right in the end. Divide by 4, k equals 4. To go from this step to this step, I added this k to both sides. So I added k to get rid of it here, and when I add k to 3k, you get 4k. Any other questions?
And then we would plug that into the original equation.
Make sure it works. 3 times 4 is 12. 12 minus 11 is 1. The square root of 1 is still 1. 5 minus 4 is 1. The square root of 1 is still 1. 1 is equal to 1. So yay, it works.
And if...
You get excited like that when it works, right, Emma? Saw that.
Yep.
That's good. All right. One last one. One last one.
I'm just excited.
You too, Lily?
Yeah, so...
Right away.
Lily's excited about that?
All right, let's do this one. X equals 5 plus the quantity 3x minus 11 to the 1/2 power. Don't let the 1/2 power mess with you. Really, the 1/2 power is just what? Square root. So most of you will just rewrite the problem. X equals 5 plus the square root of 3x minus 11. Now, looks like what we've been doing. What do you want to do?
Subtract 5.
I would rather subtract the 5 than square it. Because if I square it, I have to take this times itself, which will involve a lot of distributing, and you'll still have radicals in it. Okay? Real quick, guys, if I take that times itself,
I don't want to.
you would get 25 plus 5 radical 3x minus 11 plus 5 radical 3x minus 11 plus 3x minus 11. Okay? Now, problems 18 and 20 I do think require you to have to do that. Okay? I'm probably not going to throw one that difficult on your test since we're kind of running out of time on the semester, but it's not bad. I mean, we could do it. In fact, I would challenge some of you that math comes fairly easy for to go ahead and try those. I think that'd be good for you. Okay, but I'm not going to put that one on a test. Okay? I would subtract the 5 first. And now do what?
Square the square root.
Now square both sides. Okay? Right side is simply 3x minus 11. When you take x minus 5 and you square it, you got to remember to take x minus 5 times itself. So x minus 5 times another x minus 5. Okay? X minus 5 times x minus 5. You got to distribute. You guys were doing these in your head with that Pythagorean triple.
X squared plus 10?
X squared
No, plus
minus
25.
10x plus 25.
Wait, why wouldn't it be plus 10 if you're doing...
X minus 5, x minus 5, x squared, minus 5x, minus 5x, plus 25.
Okay.
Right? Remember that? Now you have a quadratic equation. How do you solve quadratic equations? Set them to 0. Hope you can factor it so you don't have to use the quadratic formula. X squared
Minus 13x.
minus 13x
Plus 36.
plus 36
Equals 0.
equals 0. I like that one. You can factor it. What are the factors?
Oh my
Multiplies to 36.
Yeah.
god. 9 and 4?
6
Yeah.
and 6.
9 and 4.
Both negative?
X minus 4.
6 and 6 do multiply to 36. You're not wrong. But I can't make them add together to get a negative 13. So let's go with 9 and 4, both negative. X minus 9, x minus 4.
X equals 9.
Set your factors to 0 and solve, so x will end up equaling 9, x will end up equaling 4. Two answers. Be very wary of whether or not they both work. Sometimes they do, sometimes they don't. Let's try it. 3 times 9,
27.
minus 11,
16.
square root of 16,
4.
plus 5,
9.
9. That worked. 4, 3 times 4,
12.
minus 11,
1.
square root of 1,
1.
plus 5.
6.
Eh.
Extraneous.
That was an extraneous solution. Does not work in the original problem. It showed up because we squared both sides of an equal sign, which means we were squaring a variable, which usually adds in a solution that does not end up satisfying the original equation.